Hello, I'm Professor Anthony Joseph, and welcome to Data Science 100 for undergraduates and Data Science 200 for graduate students. We have a lot of material to go through today. So we're going to start with some introductions of the professors teaching this class. Then we'll talk about what is data science and what you're going to learn in this course. We'll provide an overview of the course and its logistics. The logistics are quite different from prior years, and because this is an all online class. And then we'll talk about the data science lifecycle, and we'll do a demonstration using real-world data. So let's start with introductions. I'm Professor Anthony Joseph. I'm a Chancellor's Professor in Electrical Engineering and Computer Science, and normally you'd find me on campus in 465 SOTA, also known as the RISE Lab. A bit of a fun fact, I'm the Campus Cyber Risk Responsible Executive. That's the person on each UC campus who's responsible for interpreting UC policy about cybersecurity and overseeing the implementation of that policy on the campus. Now, I've done research in a lot of different areas, and my active research projects include a project very relevant to this class, and that's called Modin. It's a drop-in replacement for Pandas that's up to 100 times faster and allows you to work with gigabytes of data. I also have a project called Atom, where we're developing algorithms for working with cancer genomics and precision medicine using Apache Spark. I also have a project that's on secure machine learning. That's machine learning in the presence of adversaries who are actively trying to manipulate that machine learning algorithm. I also co-operate the world's largest public cybersecurity testbed called Deter Lab. I've done a lot of prior research in cloud computing, peer-to-peer networking, mobile computing, and wireless and cellular networking. Now, outside of my core research and teaching activities, I've also taught online courses before. In 2015 and 2016, I taught several courses around big data and Apache Spark. We had over 240,000 students enroll in the classes, and we had an average completion rate of over 11%. I'm also a co-founder of a startup called Unite Genomics, where we're focused on accelerating the development of new treatments and cures for patients with rare diseases. And now I'd like to turn it over to my colleague who's co-teaching the class with me, Professor Fernando Perez.
Hello, everyone. My name is Fernando Perez, and I'd like to introduce myself to you and welcome you to the 2020 fall edition of the Data 100 course, which I will be co-teaching with my co-instructor, Professor Anthony Joseph, and the rest of our wonderful instructional team. I'm faculty in statistics. I've been in the department since 2017, but I actually came to UC Berkeley back in 2008, originally as a research scientist working at the Helen Wills Institute, building computational tools for neuroscience. My background is actually in the physical sciences. I was trained as a physicist, and I did my postdoc in applied mathematics, both of them at the University of Colorado in Boulder, mostly working basically on computational physics problems, and computing has been kind of a constant of my career. For a long time, I've been interested in building open tools for science and open source tools for computational research, especially in Python. I fell in love with the language back when I was a graduate student, used it in my research, and in 2001, a little bit of productive procrastination led to the creation of IPython, and me becoming quite involved with the rest of the, at the time, nascent scientific Python ecosystem, collaborating on projects like Matplotlib, NumPy, SciPy, and the growth of that ecosystem. That led in 2012 to co-founding NumFocus, which is a nonprofit that supports open source tools for science. And in 2014, as the original ideas in IPython had grown, thanks to the work of many wonderful colleagues, and having become a big collaborative project whose scope went beyond Python, we sort of extended it and created jointly a project called Jupyter, which is a tool that we will be using in this course. And those of you who have taken Data 8 already may have already encountered it, as it is the platform that supports the data hubs that we use on campus for these courses and the Jupyter notebooks that we use for a lot of our class materials. And this year, with others from UC Berkeley, University of British Columbia in Vancouver, Canada, and Columbia University in New York, I've had the pleasure of co-founding yet another nonprofit related to computation and science and education called 2i2c, which supports the development of interactive computing tools for research, especially in the cloud and teaching. From a research perspective, my interests combine precisely the development of these open interactive tools for research and teaching, and with the usage and development of methods from data science in the physical sciences, kind of going back to my roots, but instead of working in the domain of particle physics, which is what my training was in, working more specifically in applied problems in geoscience. I find that the geosciences present some really fascinating research challenges in terms of combining our knowledge of principled models of the world that are driven by equations, conservation laws, symmetries, the kind of mental framework that we use in the physical sciences, together with uncontrolled noise, stochasticity, and the variability of the real world that make geoscience problems a fascinating arena to explore the intersection of physics and data science. If any of you are interested in those topics, I'll be teaching a course precisely exploring that space in the spring of 2021, Stat 157. And more specifically from within the geosciences, since that is still a very large context, I'm particularly interested in applications to the cryosphere, meaning the study of the ice on Earth. I'm a mountaineer. The study of ice fascinates me personally, but it is also one of the most critical spaces where climate change manifests itself. The melting of our ice caps, of the loss of our mountain glaciers that connect to water resources in many parts of the world is an absolutely critical problem that we need to understand. So it's not only scientifically interesting, but also socially very relevant. So that is what I tend to spend my time on these days. It's both computation and these kinds of application domains. But in this course, we're going to explore many of the foundations of these ideas, both theoretical and practical. And I am delighted to welcome you all to the course. I look forward to getting to know you. I want to recognize that this is going to be a challenging semester. The world is in a very complicated place right now, given everything that is happening, both socially and related to the pandemic. And we will do our very best to accommodate your needs and to try to make this a productive and intellectually stimulating semester, acknowledging these circumstances. So welcome, everyone. It's a pleasure being here with you.